Hello, this lesson video today is a review lesson on 6.5 and 6.6, exponential growth, exponential decay. Okay, so if you have your practice sheets, I know that a lot of you have already uploaded them to me, but if you have them, why don't you take them out and let's go through all these examples together. This will be a short video today. Thank you. 6.5 practice. Okay, so these are exponential. This is growth. Okay, so we're looking for growth on 6.5. All right, so we're gonna go through all of these answers together, and we will cover everything on them. Okay. 6.5 practice, it says, identify the initial amount A and the rate of growth as a percent of the exponential function. Evaluate the function when t equals 4. Round your answer to the nearest tenth. Okay, so this number that's in front here, this 250, is going to be your initial amount. Okay, so your 250 is your initial amount. And you can see this is a growth function because this is 1 plus r is equal to 1.01. So 1 plus r equals 1.01. And if I was to subtract r1 from both sides, I would have 0.01 is equal to r. Now that's a decimal equivalent. So in this case, it's 1%. 1% growth, okay? Now, if it asks you to evaluate the function when t is equal to 4, you're simply going to take this t and you're going to put a 4 there. So you're evaluating y is equal to 250, okay, times 1.01 raised to the 4th power, okay? And by doing that work, you have 260. 260.2. So that's how you do these problems. They're fairly straightforward in this practice for growth. As you can see with number 1, that front number is 250. The growth is 1% growth, okay? And then if you do this calculator work here, 1.01 raised to the 4th power, multiply it times 250, you're going to get 260.2. So for this number 2, you can see you've got this 14 out in front. That is going to be your initial amount. 14 is the initial amount. The rate is this 0.35 or 35%. And if you were to evaluate this f at t or f at 4, that will be the initial amount 14 times 1.35 raised to the t power or 4th power. And that's 46.5. Okay, so 1.35 times 1.35 times 1.35 times 1.35 times 14 will get you 46.5. Or you could use your power button on your calculator. All right, so growth here. So in this case, 4.2 times 1.9 to the t power. Your initial amount is 4.2. Your rate here is 90% growth. And if you raise that to the 4th power, it's 54.7. 54.7. Number 4, you have the initial amount to be 1,800 here. The rate is 5.9%. Now, how did you get that? That'd be 1 plus the rate equals 1.059. And by subtracting 1 from both sides, you would have your rate is equal to 0.059, and that's the decimal, okay? And we're going to move that over 2 spots to get 5.9%. And lastly, if you evaluated that function at 4, you're going to take 1,800. You're going to multiply it times 1.059, and you're going to raise it to the 4th power. And that would be 2,263.9 for number 4. So exponential growth, the front number is the initial amount. The rate that it's moving up is calculated. It's always that decimal, move the decimal over, and you have yourselves your percentage. Number 5 on this problem, credit card debt. Okay, so credit card debt started at $1,100, and your debt increases 28% each year. Okay, so the graph here, and I've told a few students, you know, I want you to understand how the graph goes, understand what that initial amount here means, and that means where your debt is starting out at, 1,100. You can see right down here, your exponential growth. And this is 28%, so it's increasing at a 1.28 raised to the time, okay? Now, if you think about this, this is growing at a pretty good pace, okay? And at $1,100, and if it's going up 28, after 1 year, you're right here, 2 years, you're here, 3 years, you're above 2,000, 4, and so forth. It grows exponentially. It's a growth. Okay, so right graph a function, the graph of the function would be here in this box or this rectangle, and the graph would look like this. Okay, exponential growth of a credit card. Couple things to note. This is the 0 term. Okay, so this is when t is equal to 0. That's your initial amount. So if you think about it, this is y is equal to 1,100 times 1.28 to the 0. Okay, anything to the 0 is 1, so y would equal 1,100. So oftentimes that first initial amount is called the 0 month. Okay, and then 1 month would be after 1 month, or 1 year, I should say, and so forth. Okay, so this next one, we are 6.5 practice for use after less than 6.5 is a deposit, 675 in an account, 3.4% annual interest compounded twice a year. It says write a function that represents the situation. Okay, so for this one, a couple things to note here on this question. It has an annual rate of 3.4%. So if it's compounded twice a year, what that's going to put you at is the interest rate of 1.017 growth, and it's 2 times t because it's twice a year. Okay, so find the balance in the account after 2.5 years. You would put your 2.5 in for t and evaluate the function. You had $734.36. Okay, that would be using your interest. Now we're going to go on to your decay worksheet. So if you have that, you have your work here. So this was decay. Okay, so you're given these charts here, tables with x and y, and you want to look at this y and see what it's doing. Okay, and if you can see a pattern of growth, exponential growth multiplied by the same thing each time, it's a growth. If it's multiplied by the same thing each time, it could be a decay, or it could be neither. Okay, so this first one's a decay. Okay, what it's doing is it's going down. Okay, so in this case, it's going down by a third. So we're multiplying by 1/3 each time. And that's an exponential decay answer. So, and as you can see, the x is going up by 1 each time. It's an exponential decay. Number 2 is neither 0 to 1, 1 to 2, 2 to 3. As you can see, this goes down by 12, and then it goes down by 12, and it goes down by 12. But this is neither exponential growth or decay, okay? So it's neither exponential growth or decay. Number 3 is growth, exponential growth, and it's exponential growth because when you go from 4 to 28, you're multiplying by 7. 28 to 196, you're multiplying by 7. 196 to 1372, you're multiplying by 7. And the last one, you're going down x at a 2. So to get from 3,000 to 300, you're dividing by 2. So this is a decay also, exponential decay. So answer for 1 is decay. 2 is neither. It's not multiplied, it's just subtracted. This is actually a linear. 3 is growth, and 4th is decay. Write the rate of decay as a function as a percent. Okay, so the rate of decay in this case is 1 minus the r is equal to 0.78. Okay, so likewise over here, 1 minus the r is going to be 0.4. Okay, I took 2/5 and I changed it to a decimal, 0.4. So 1 minus r, if I subtract, so what number are you subtracting from 1 to get 0.78? I have myself 0.22. Okay, so r is equal to 0.22. So your decay is 22%. In this case, your r is going to be 0.6. So you have a 60% decay for number 6. So we're going to look at this last one. The mass of a radioactive element is 35 milligrams. So that's your initial amount, 35. The mass of the element decreases at 12.9% every year. Okay, so it is 1 minus the r is going to be 12.9%. So 1 minus the 0.129 is equal to that number. So 1 minus 0.129, I used my calculator for that, was 0.871. So initial amount 35 times 0.871 raised to the t. Predict the mass of the element in 4 years. Round your answers to the nearest tenth. So we got 35 times 0.871, and we're gonna figure that out to the 4th, 4 years. Okay. So I'm just going to use my calculator quickly. 0.871 to the 4th. And then I'm going to multiply that times the initial 35. 20. How about 20? It said rounded to the nearest tenth, and it was 20.1 So my answer is 20.1. And that concludes 6.6 practice. Hopefully you found this helpful. Nothing new today, but I do want you to make sure that you go through your correcting those 6.5 and 6.6, and be on the lookout for a little quiz tomorrow. All right. Thank you very much. Have a great day.